Hi there, I'm Mike Glass with Orion Technical Solutions. Um, I'm going to talk today about a recent question that I posed on LinkedIn having to do kind of with forces and also having to do with how outputs behave with forces and so forth. Um, in this particular program that I've written, basically this is just a training program. It's not a real system. It's made to demonstrate and teach things, so you wouldn't want to copy this for sure. But basically what I have is I have a start stop run bit in the top rung, just a normal seal, and then I have that run bit used as kind of a permissive in the next rung that feeds this motor input 4 switch, which is going to be this guy. So the idea is when I hit the start button, this will seal in, this is ready to go. The logic basically is such that when I turn input 4 on, the pump, which is this guy, should turn on. So test that out, and it does. And the logic has a condition in this next rung that looks at the pump 100 output, and if it's on, then it energizes output 11, which is the cooling fan here. So this code is what I call spaghetti code. This is one version of spaghetti code. The spec said, when pump 100 runs, fan 100 should run, something like that. Well, a lot of times the coders, the programmers, they just throw the closest thing to that sentence. AI will do this if you're not careful, if you don't control it and keep it from doing it. So anyway, it's trying to keep the fan 100 should be running whenever pump 100 is on, because we're going to pretend this is a giant motor that needs cooling, and this is the cooling. Pretty typical scenario where there's a condition that's needed. So in this particular setup, I'm going to theorize that, or make a hypothetical situation, that input 4, the motor run switch here, is failed. It won't close. It won't make contact. So managers want the pump running. They want this. They want production. So they're like, find a way. And so some technician goes out there and he says, well, I know how to do this. I saw somebody do a force once. I'll do that. So he goes over here, does the steps. He says, well, forces are enabled on this particular program, so we'll skip that. We'll talk details of forces later. He right clicks that, says force on. Well, guess what? It's on. It literally turned that on. So he reports back, got it, sir. We're good to go. Of course, sometime later, they start smelling, there's smoke everywhere, and they start smelling because you'll notice the cooling fan isn't running. And if you look here, you'll notice it's not told to run. Well, if you look back, pump 100 isn't even green. It isn't on. Well, there's two parts to a force on an output. There's the value, which is kind of the real condition, which is what logic looks at, which is a 0 right now. Because when it scans this, it doesn't really look at the force. That happens afterward. It sends the force mask to the actual output. It's almost like a jumper at the output. It doesn't even look at it in the logic. So what happens is that just gets forced on, which it is. It's forced on kind of right here, essentially. You can think of it as. So the problem then is that since that's not on, it's a 0 in the logic or the value portion. So when this next rung, when it's executing and it sees output 8 is on, it sees that it's a 0, well, it doesn't meet its examine on condition. So it makes sure that the fan 100 is also a 0. So you see here, fan 100 is a 0. So the only way really to get that on would be to force it also, or to go in here and actually fix the real problem. So I'm going to go ahead and, for now, I'm going to remove this force. And I'm going to talk about, like, there's different solutions here. So basically, the fact that you force an output, it will not cause any spots in that logic that look at that as an input condition to be true. It'll be whatever it is in logic. So the better solution for this would have been to force the real problem, which is the input. If the output's bad, you can't force it. If the input's bad, you can force it. Generally, it's much better to force inputs than outputs. When you force outputs, there's a lot of weirdness that can happen, and this is just one of them. A lot of times, for not great reasons, sometimes outputs show up more than once in a program, especially if programmers come from a world where they do a lot of jump type stuff and a lot of different subroutines and calls and things like that. They tend to do that a lot. It's bad code, but you'll see it. I've been with Fortune 100 companies, and this kind of crap is all through their programs. It's crazy, but it's there. So basically, in this case, the right answer would have been to force. If it wouldn't work, we can't fix it, we would force this. Well, now another benefit of that is that we can still control the run bit. So we still have some on-off control. So it's a better solution. Again, this whole code snippet is bad. Everything about it is bad. I'm trying to show things that that you can learn from. So these little snippets I give you in these blogs and or even in classes are not meant to be this is how to do it. It's kind of this is how not to do it, but more importantly, this is how this works and why it works. Hopefully that makes sense, and hopefully you get something out of that. And feel free to comment, give me questions, whatever, and ideas for other blogs. Thanks.